Okay, this is starting chapter 3, and this is 3.1. Now, 3.1 deals with polynomial equations. Excuse me. If you remember what polynomials were, polynomials are stuff like x squared minus x and minus 12. That's a polynomial because it's has a power and it reduces in power and it has the plus and minus sign in between it. It can be factored into x plus 3 and minus the 3 and x plus or minus actually 4. So you can be factored into these. You remember doing these either by the equation, the negative b plus or minus square root of b squared minus 4ac over 2a, or just figuring out what the middle number is by using this guy, the constant. And then we started setting them to 0. So we would take a larger polynomial and we would set it to 0 to figure out if it's equal to it, or after solution you can plug it back in and make sure it equals. This deals with other ways of dealing with polynomials to be able to factor out polynomials easier. So the first one is called the rational zero theorem. And I'm going to attempt to write that on here. Theorem. Okay. Rational zero theorem. This says that there are possible zeros in a polynomial. I think the best way to describe this is just show you how to do it. Let's say we have a polynomial x to the 4th plus 2x cubed minus 7x squared minus 8x plus 12. Excuse me. So the factors of this, so let's learn what we need to do to know what the factors are for this rational zero theorem. This right here, this 12 is a constant. This is a coefficient if it's in front of an x. This constant and this leading coefficient is what we need to figure this out. So let's start with the coefficient, the 12. And we need to represent it as plus or minus. So the coefficients of 12, I'm sorry, not coefficients. The factors of 12 are 1, actually plus and minus 1. 2 will go into it, so plus and minus 2. And 3 times 4 is 12, so we'll go there. Uh-oh, what did I do? I wrote down a 4. 3. Now, 4 times 3 is 12, so it's 1. 6 times 2 is 12, so we're going to do that. And then I think the last one is just 12. Okay. Now, let's get the ones for 1. So here's 1. And I think the only one for 1 is just 1. Now, if it's a leading coefficient and it's positive, it's always just going to be positive. Here, it's not plus and negative because you can't change the sign on a coefficient. Not that easily anyway. So what you do next is to find out the possible zeros, you need to list the ratios. So you put this, you start here and you put it over that. And I'll describe that in a minute, but you just go down the line and put it over the first one. So we would have 1 over 1 plus or minus. We would have 2 over 1 plus or minus. And I'm taking this 3 and putting it over 1. And so on. So what we come up with is ratios or numbers that will help us describe the zeros in this polynomial. Now, we need to simplify. Now, to simplify this, it's easy because all these are over 1, and we would just write 1. So basically, we're coming up with the same thing that we had for the factors of 12. All right, so plus or minus 4, plus or minus 6, and plus or minus 12. Okay. Now, those are the possible rational zeros of the polynomial, this polynomial right here. I'm sorry, this polynomial. X to the 4th plus 2x to the 3rd minus 2x squared. That's the possible rational zeros of the polynomial, which is why it's called the rational zero theorem. Okay. Let's do another one. Just want to draw a line here. 2x to the 3rd plus 5x squared plus x minus 2. So what we do is we find factors of that and the factors of that. Expand the screen a little bit. So the factors of this two right here, the one we're doing, is plus and minus 1 and plus and minus 2. The factors of this 2 are 1 plus and plus 2. That's it. So this is how we do this. Expanding my screen some more. Now, we take this one, put it over this one, and then we take this one and put it over this one. And then we take this one and put it over this one, and then this one and put it over this one. Hope that makes sense. But this is plus or minus 1 over 1. And then we have this one, which is plus and minus 1 over 2. And then we have this one to this one, which is 2 over 1 plus or minus. And then we have plus or minus 1 over, I'm sorry, 2 over 2. Now, we need to simplify this. There is a good way we can simplify this. 1 over 1 is just 1 plus or minus 1. 1 over 2, I can't really simplify that. So 1 over 2. 2 over 1 is just 2. And 2 over 2 is 1. We already have 1 right here. This is our 1. So we will just leave the 1 there and not add another one because there's no need to. And that is the possible rational zeros for that polynomial. Now you may be asking, what in the world are we going to do with this? Well, that's going to come up later. I think you'll enjoy it. Right now, let's get these theorems out of the way because there are a few theorems that we need to learn before we can put them together and make use of them. Okay. Clearing my screen. Next one is factor theorem. I'm going to write it on the board. Factor theorem. Oof, can't write. Okay. The factor theorem states that a polynomial has a factor if and only if the polynomial is equal to 0. So what does that mean? Well, let's do 1 and you'll see what it looks like. So let's say, and this is how they give it to you. Let's say they're going to ask the question, is x plus 2 a factor of x to the 4th minus x third minus 7x squared plus x plus 6. So is x plus 2 a factor of this polynomial here? This is how we determine that. Excuse me. So okay. So first thing you do is you set this to 0. You solve for x. So in this case, x is equal to -2. Okay. Now, this -2, we need to substitute. We see that what x is equal to here, you substitute into here. So we would have -2 to the power of 4 minus -2 to the power of 3 minus 7 times -2 to the power of 2 plus just -2 and plus 6. So let's go ahead and solve this then. So -2 to the power of 4. What is that? Well, how we figure it? Well, we got a calculator, right? So we can plug in our -2 and we just raise it to the power of 4. Now, how do you raise it to the power of 4? There should be a way to raise it on your calculator to a power of 4. I don't think I can help you with that, but one way you can do it is just say 2 times 2 times 2 times 2. And that would give you 16. Now, what happens to the negative? Well, a negative times a negative is a positive, and a positive times a negative is a negative. That's 4 of them. 1, 2, 3, 4. So that comes out to be, or supposedly, a negative. So actually, -2 times -2 times -2 times -2 times -2 for 4 is actually 16. So the next one will be -2 times -2 times -2, which is -8. But you got this negative here, so it's +8. This one turns out to be -28. -7 times -2 times -2 plus -2, which is actually just -2 and +6. And if you add this up, 16 plus 8. Well, let's get the calculator. I don't know if you guys can see my calculator. 16 plus 8 is 24. Minus 28 is -4. Minus 2 is -6. Plus 6 is 0. So this equals 0. Now, what does that tell us? That tells us that x plus 2 is a factor of this polynomial. Okay, so yes, it is a factor. We answered the question, is x plus 2 a factor of this polynomial here? Let's do another one. We have determine f x minus 2, x4, x3. So, okay, determine if x minus 2 is a factor of the original polynomial here. So if we set this to 0 and we say x equals 2, we'll say that 2 to the power of 4 minus 2 to the power of 3 minus 7 times 2 to the power of 2 plus 2 plus 6. Okay. And if we solve this, we'll have 16 minus 8 minus 28 plus 2 plus 6. And that, if we use the calculator, 16 minus 8 minus 28 gives us -20 plus 2, -18, and then plus 6, which is actually -12. So this is not 0. So x minus 2 is not a factor of this polynomial. Okay. That is the factor theorem. All right, let's move forward to synthetic division. It doesn't sound as bad as it doesn't. It isn't the sound. You know what I'm trying to say. Not as bad as it sounds. With synthetic division, we can find the. Let me just write synthetic division. So we're having synthetic division. Hopefully this is trying to keep this separate in your notes so you can go back and look it up if you need it. So they're going to give you the same type of thing as the factor theorem. We'll just work through one. I think that's the best way to learn what this is and how to do it. But what this does is helps you factor out polynomials. And you'll I think you'll be like, oh, why couldn't we do this before? But I'm not sure, but um, I think you'll like it. So let's say we have the factor, and we're starting it this way, but we have a factor of x minus 1. Okay. We want to remove that factor from x to the fourth plus 2x cubed minus 7x squared minus 8x plus 12. Okay. How do we do that? Well, here we'll solve for x. Let's set it to 0. We'll say x equals 1. Okay. Now we know we have a 1. Let's write that 1 right here. And let's draw a box like this. This is an upside down box, kind of like our factoring trees. Now, let's write the coefficients and the constant down. So for this x4, we have a coefficient of 1. So there's a 1 in front of that. This one has a 2. This one has a -7. This one is a -8. And this is just 12. Okay. Now, this is how we do this. We drop down our 1 to here. Okay. And then we multiply this number with this number. 1 times 1, well, that's just 1. And we'll write it right there. Now, we're going to add. 2 plus 1 is 3. Okay. Then we're going to repeat. Multiply this number with this number now, which is just 3. Then we're going to add. -7 plus 3 is -4. And yes, you guessed it. We're going to multiply 1 with -4, and we'll get -4. And then we're going to add. So we're just repeating the process over and over. And -8 plus -4 is -12. And now we're going to multiply 1 times -12, this guy right here, and we get -12. 12 minus 12 is just 0. Okay. Now, what did that help us figure out? Well, that helped us figure out that x minus 1 can be removed from this polynomial here. And what we do is rewrite it as x minus 1. And now when you rewrite this, you see how this x to the fourth is here? Well, we don't worry about that anymore because we pulled out this x minus 1 from this whole polynomial. So we start with a 1 down. We start with, instead of the x to the fourth, we start with x to the third. Now, if it was x to the fifth, we'd start with x to the fourth. Or if it was x squared, we start with x, which I doubt you'll have that. If it was x to the 3, we start with x squared. Does that make sense? I hope. So what we'll do is we have a coefficient of 1 right here. I'm going to attach that to the x to the third. Okay. We have a coefficient of 3 right here, and it's positive. And we're going to say x squared. This one is -4 minus 4x. And then the next one, because we've run out of coefficients, this one is our constant. So we're going to say minus 12. We have successfully factored this polynomial 1 time into x minus 1. Now that was a heck of a lot easier than what we've been trying to do before. All right, let's try another one. Now, this one. So sometimes a polynomial will not have all the powers, okay? So you have to represent those powers in a different way. So just putting the coefficient of 0 is sufficient in doing that. And let me show you that. Let me just draw a line right here. So let's say we need to remove x plus 2, or see if we can remove, from x to the fourth minus 3x squared minus 4. Now, as you notice, we don't have a descending order. There's no x to the third and there's no x. Well, this is how you do that. You rewrite this to x to the fourth minus 0 x to the third. Okay. Now, why not choose minus? I just shouldn't have choose minus. I'm sorry. Plus 0 x to the third. Okay. Now minus 3x squared plus 0x minus 4. You see, I just filled in the missing 3 and the missing 1. This is x to the 1, basically. Okay. Now, this is how we do it then. We just go about our business like we did on the other one. We solve this one for x, which will be x equals -2. And then we use our little box theory. Drop it down like that. And we fill in the coefficients. Coefficient of 1, coefficient of 0, -3, another 0, and a -4. We drop down our 1 and we begin multiplying. -2 times 1 is -2. And if you add this, 0 minus 2 is just -2. 2 times 2, I'm sorry, -2 times -2 is actually +4. And -3 plus 4 will give you 1. -2 times 1 is -2. And of course, 0 plus -2 is just -2. And then we repeat. -2 times -2 is just 4. And that gives us a 0 here. So yes, we can say that they can pull this out. Now, let's rewrite it as a factored solution. X plus 2. Now, we started with x to the fourth here. So this one will start with x to the third. So we're just going to write x to the third because there's an understood 1 in front of that. Minus 2x squared plus x minus 2. Okay. All right. That is synthetic division. Awesome stuff. Helps you factor out these things quite easily. Okay. Now, having said that, there is one more theory that we need to learn before we can put all this into practice. It's the remainder theorem. All right, so I'm going to write this down. Oh, there we go. That's kind of an R. Remainder theorem. Okay, remainder theorem. Whew, hard to write with this thing. Now, remainder theorem states that the remainder from the synthetic division is equal to the expression evaluated at K. Now, what the heck is K? Well, if it's equal to the expression that X minus K or X plus K, it's the factor. Like a while ago, we had X plus 2, X minus 2. If it's equal to that, then we can evaluate the polynomial. So let's just do one, and then maybe that will make more sense because division. Okay. So what we're going to pull out of the remainder theorem, there's not really any work to do from it because we've already done the synthetic division, is that if the remainder, so the remainder is this last bit here, if it's not 0, if it's something else than 0, then you cannot factor that out of the polynomial. Okay. I think I stated that while I was working with it, but I just wanted to make sure that you understood. If it is not 0, then you cannot factor it, and you're done. Okay. All right. We'll run into that, and it's just a concept you need to understand. Now, moving forward, let's put all these theorems into play, into practice. Let's say that we have a polynomial that is x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24 equals 0. Oh, okay. That's big, long, but trust me, you'll like this. Now, first thing we need to do is pull out the factors, the possible factors of this polynomial. Now, if you remember how to do that, we took the constant, which is this number here, the 24, and the leading coefficient, and we took the factors of them. So I'm just going to do it long ways. So 24 factors are plus and minus 1, and 2 will go into 24, because 2 times 12 is 24. 3 will go in 24, and 4 will go into 24. 3 times 4. Actually 3 times 6. So anyway, 6 actually will go into 24. I just talked myself into that one. And then 8 will go into 24. Now you're asking, how do you know this? How do you know that these numbers will go into 24? Well, there's an easy way to figure it out, and you can do it on your calculator. Just start with 1 and go forward. So 24 divided by 1, we all know that'll go into it. 2, we know 2 will go into it because it's an even number. 3, so 24 divided by 3. If it comes out to be a real number, then yes, you write it down. And then I just went to 4, and then I went to 5. Well, 5 don't work, so I didn't write it down. 6 will go into 24, so 24 divided by 6 gives you a 4. That's a real number, so I wrote it down. 8 will go into 24, 12 will go into 24, and oh, I don't know what I wrote down here. So this is supposed to be 24. See, I'm catching my own problems right here. Now, 24. All right, so these are the factors of the constant. Now let's find all the factors of this coefficient. It's so many of them. It's just, I don't know how we're going to do it. 1. That's so hard. I don't know what to do. Now, the next step, and we're going to go this step by step, even though we should know what these coefficients are. We're going to do this step by step. We should take each of these and put it over this number. Remember? Okay. So we're going to do this by saying 1 over 1 plus or minus 2 over 1, and then 3 over 1, 4 over 1, 6 over 1, 8 over 1. That's supposed to be an 8. 12 over 1, and 24 over 1. Then we need to simplify. Well, simplification is just those numbers, right? So we really didn't have to do this step because we know it's all over 1, but I did it just to show you that sometimes you have to follow the steps, because sometimes it's not just 1. It could be something else. It could have been 2 or 4 or 1, 2, and 4 or whatever. And you'd be ended up with a lot of these. But right now, it's just 1, 2, 3, 4, 6, 8, 12, and 24. Okay. Now, this is how we find the possible factors of this original polynomial. This is the original polynomial right here. This is how we do it. We start with 1, the smallest, easiest one. Now, let's plug it in. Oh, you say, what do you mean when you say plug it in? Well, we're going to find a valid 0 by evaluation. So we take this polynomial, x to the 4th, we plug in the 1 for x. So 1 to the 4th plus 2, 1 cubed minus 13, 1 squared minus 14, 1 plus 24. And then we need to evaluate that. So this is just 1 to the 4th power is 1, plus 2 to the 1 power is just 2, minus 13, minus 14, plus 24. And what does this equal? Well, we can use our handy dandy calculator. And our handy dandy calculator says 1 plus 2 equals 3, minus 13 equals negative 10, minus 14 equals 24, plus 24 equals 0. So this equals 0. Hey, that means we can factor this. So let's do it. Let's factor it. Then you're like, oh, how do we factor this? Well, let's use another theorem. So what theorems have we used so far? Let's think about that. We use the rational 0 theorem and the factor theorem. What? Are you sure? Yeah, we have. Look. Well, if you look back in your notes, the rational 0 theorem was the first thing we learned. We used that. We did the factors. And that's how we found these factors right here. And then we used the factor theorem, which said that if you take the if you take the solution and you plug it back into it, if it equals 0, then it can be factored out and it will be a factor. Now we're going to use the division, the synthetic division, to actually factor it out. So let's do it. We have a 1, so this is the first one, and that's the one we plugged into here. We're going to do it like this. And then we're going to write down our factors. So the factors of this are 1, 2, negative 13, negative 14, and 24. So 1, 2, negative 13, negative 14, and 24. Pull your 1 down. 1 times 1 is 1. We're adding here. Gave me a 3. 1 times 3 is just 3 as far as I know. We add this. That gave us a negative 10. 1 times 10 is negative 10, I'm sorry, is negative 10. That gives us a negative 24. And 1 times negative 24 is just negative 24, which gave us a 0. Now, we can now write this as a factor. We used this 1 right here, okay? Now, I can write that 1 as x minus 1. Now you say, why? The reason is because set it to 0 and then solve it. So we'll add 1 to both sides and x equals 1. So I wanted x to equal 1. So I reversed this process. I moved x back over. So essentially I said negative 1 and then x negative 1 equals 0. That's where I got that from. Okay, so now we can say x minus 1. And this started with x to the 4th. So I'm going to start with x to the 3rd and write in my coefficient, which is just 1, plus 3x squared minus 10x minus 24. Okay. Now, let's do it again. Now, what do you mean when I say let's do it again? Well, let's factor out some more. So do we think we can factor out more of this? And what will we use to factor out more? Well, we used 1 of the possible factors. Let's try 2. So 2 is right here. That's the next possible factors. Let's repeat this process and see if it will work. So we will use the rational zero theorem. No, I'm sorry, the factor theorem. This theorem right here. This right here is a factor theorem. We're going to do it again. And then we're going to use synthetic division, this section here. We'll use that to factor out further if and only if this 0 occurs on this 2 right here. Now let's try it. So we have the x to the 4th. Okay, let's see here. Should I just draw a little dotted line here? Okay. Let's do a 2 to the 4th plus 2 times 2 to the 3rd minus 13 2 squared minus 14 2. plus 24. Okay, so actually, that don't make sense to me, and that's not right. Sorry, guys. Erase. It wouldn't make sense to go back to the original equation and see if it fit. We have to go use this equation, the one we created, to see if the 2 here will fit. So let's do this. 2x cubed plus 3, 2 minus 10, 2 minus 24. Okay. Now let's solve this. So 2, why is it negative 2? Why are we doing negative 2? Since reduced volume is not trial, we're trying another valid solution. Oh, well, 2. We're doing 2 right now. Let's see if 2 works. 2 times 2 times 2 is what? It's 8, right? Plus 3 times 2. Oh, this is 2 squared. 2 times 2 is 4 times 3 is 12. All right. So this would be minus 20, minus 24. Let's see what this equals. Okay, so 8 plus 12 minus 20 equals, wait, 8 plus 12 minus 20 minus 24. So we got a negative 24 here. Okay, so that didn't work. We got a negative 24. What do we do next? Well, if you see here, this is a plus 2 and a minus 2. Now we're going to try the negative 2 and see if it works. Writing it down. So negative 2 times 3 times negative 2 times negative 2 is actually negative 8 plus 3 times negative 2 times negative 2 is 4. This is 12. This is actually plus 20 now. And this is minus 24. So can I hand it in a calculator? 8 negative plus 12 equals 4 plus 20 equals 24 and minus 24 equals 0. That equals 0. Okay. So remember your plus and your minus. Now we know that negative 2 will work. We need to plug in negative 2. Get this space for us. There we go. That's a little bit of space anyway. Good grief. I need more space. All right. Let's do our negative 2. We're doing synthetic division now. We'll write down our coefficients, which were from this here, this right here. So we're doing 1, 3, negative 10, and negative 24. Bring down our first one. -2 times 1, just -2. We're going to add these and we get 1. We get -2 here. Add these and you get -12. -2 times -12 is plus 24. And that equals 0. Okay. So now we can rewrite this. Not wow. Now we can rewrite this as, get this more space. Takes forever to get more space. I need space and space. Okay. We had it as x minus 1. So let's write our x minus 1. We have a -2 here. So this x equals -2. If you reverse engineer it, it's +2. So x plus, oh, no. Right there don't make sense. Putting it on x +2 on both sides makes it x +2 equals 0. Because -2 plus 2 is 0. So we're x plus 2. And this one, we were at x to the 3rd. So we're going down 1. So it looks like we're x squared plus x minus 12. So we brought it down a good bit just by doing those steps. Well, we're not done. Let's keep going. Our next number is what? Next number in our factors is 3. Let's try 3. And I need lots more space. Space, space, space. Okay. So we have this. Let's see if 3 will fit into it. And so we have 3 squared plus just 3 minus 12. 3 squared, 3 times 3, that's just 9, plus 3 minus 12. If we get our handy dandy little calculator thingies out, 9 plus 3 is 12, minus 12 is 0. 3 does work. Let's do our synthetic division. Our first one would be a 1. Our next one would be a 1. And the next one would be -12. Bring down our first one, which is 1. 3 times 1 is 3. Add them, we get 4. 3 times 4 is 12. Add them, we get 0. 3 does work. So let's go ahead and, oh, well, 3 does work by using synthetic division. Oh, we did check it here. So let's go ahead and plug this in. So this would be x equals 3. Subtract 3 out of both sides, which gives me x minus 3 equals 0. So what we had was x minus 1. Okay. X plus 2. And now x minus 3. And then we started with squared, so we're not going to start with squared now. We have a x. And then we have a 4, so minus 4. And that's as far as you can go. So the solutions, oh, sorry. solutions to this problem are x minus 1 equals 0, x plus 2 equals 0, x minus 3 equals 0, and x minus 4 equals 0. So this will be x equals 1, x equals negative 2, x equals 3, and x equals 4. Those are your four solutions to this problem. Okay. Now, having said that, that is the end of the lesson. Keep your notes organized. It will help you. Now, I want you to do on practice 3.1. That's page 100. Well, let me just write this down. Okay, so practice. Oh boy, I cannot write. 3.1, page, I believe that's page 127. I want you to do find possible rational zeros. Okay, so you have 1, 5, and 9. I want you to do 11, 17, and 21. Okay, factor from each one. Yeah, so I also want you to do 23, 29, 37, and then solve. Okay, this is the big one. So these you'll really need to 39, put everything together, and I think you'll be able to. 40 and 41. I think you should do 45 also. There's some word problems. I'm not going to get into those right now. And okay. Do those for your homework, and I'll be around to help.